Hello, everybody. My name is Gil Rose Abadilla, and I am from Group 3 of 2DVMB. Our group will be reporting on water management and biosecurity. Today, I will be tackling water management, a guide for drinking water quality for poultry. Providing water for poultry is very beneficial as it aids in their consumption, metabolism, and nutrition, specifically in the fowl's nutrition transportation, body temperature regulation, enzymatic and chemical reactions, as well as lubrication for joints and organs, and overall completion of homeostasis. Many of the water quality standards in poultry for drinking water were originally developed from those for human drinking water, although nowadays the standards that are recommended come from research and experiments done with broilers and layers as the subjects. In evaluating drinkable water for poultry, the water should be clear, tasteless, odorless, and colorless. A reddish-brown color may indicate the presence of iron, while a blue color indicates the presence of copper. With the table shown on the slide, this is a guide for the drinking water quality for poultry. It showcases the different contaminant, characteristic, mineral, and naturally occurring compounds found in water, and its maximum acceptance level for drinkability. I will be going in greater detail, but first, I will read through the table for a better clarity of the topic. First, we have the contaminant, characteristic, or mineral. Here we have the bacteria. For the total heterotrophic bacteria, there should be 100 colony-forming units per 100 ml, or 100 milliliters. For coliform bacteria, there should only be 50 colony-forming units per 100 ml. The pH level should be at around 6.0 to 8.0. Hardness should be 110 parts per million, while in the natural occurring compounds, we have calcium, chloride, copper, iron, magnesium, manganese, nitrate, phosphorus, potassium, sodium, and sulfate, with their own varying measures of parts per million. Starting with bacteria, heterotrophic bacteria are a group of microorganisms that use organic carbon as food, such as yeast and molds, while coliform bacteria are organisms that are present in the environment and even in the feces of warm-blooded animals and in humans. The presence of these microorganisms are a result of surface contamination and should not have been present, making sure that the levels be at zero. Next, we have the pH levels of the drinking water for poultry. First of all, pH is a measure of acidity and alkalinity in a scale of 0 to 14. 7.0 being neutral, below 7.0 are considered acidic, and above 7.0 are basic. A perfect balance of 6.0 to 8.0 is needed, as anything less or more are considered unpalatable. Hardness, on the other hand, is the presence of dissolved minerals such as calcium and magnesium in either bicarbonate or sulfate form and is expressed as an equivalent of calcium carbonate. If the water has high levels of hardness, this can cause a buildup of sludge within water lines as it reduces the effectiveness of soaps and disinfectants. In addition, from what is shown on the table a few slides ago, there are a preferred or a maximum level of compounds that should be in the drinking water given to poultry. Nonetheless, many studies and research has shown that high levels of iron, manganese, and nitrates do not affect the overall growth and health of the fowl, but may damage water lines and fogging systems. Other factors that should be given equal attention are the following: turbidity, which is the measure of relative clarity of a liquid. Levels of turbidity above 5 ppm result in unpalatable water and indicate surface contamination. Temperature. The drinking water given should be around 10 degrees Celsius to 15 degrees Celsius. Toxic compounds. The amount will vary depending on the compound. However, elements such as lead, selenium, and arsenic should be kept below 1.0 ppm to prevent bird health problems and residues. And lastly, dissolved oxygen. Normal groundwater concentrations have little or no dissolved oxygen. Concentrations greater than zero are indicative of possible surface water influence. We are finally at the end of the presentation, and again, I am Rose Abadilla, and thank you for listening. Hope you enjoyed and learned a thing or two. Goodbye, everybody.